All right, so here's assignment 7.3. The first question is determine whether it diverges or converges, and if it converges, find the sum if possible. So this is a geometric series. It's exponential. All I have to look is the base. That's what r equals. Because the common ratio is equal to 2/3, this converges. This is called the geometric series test, that if the common ratio is less than 1, which it is, it does converge. And then the answer, I need the first term. So plug in 0 for n. Anything to the 0 is 1, so times 5. And then 1 subtract that common ratio, and that will give you the answer. So when you multiply times the reciprocal, the answer is 15. Number 2, press pause, see if you can try it. Again, this is geometric. The common ratio is 2/3 again, so again it converges. Why does it converge? The geometric series test, when the common ratio is smaller than 1, it converges. The formula, plug in 1 and you get 10/3, and that's divided by 1 subtract 2/3. So this is 10/3 subtract 1/3. The 3's divide out and the answer is 10. Number 3. Here the common ratio is 3, so this diverges because the common ratio is bigger than 1. Same test, the geometric series test. Number 4, we have to write this as a limit as n approaches infinity. And if you use the power terms, that's equal to 1. So this diverges. This is called the nth test, nth term test. The nth term test means that the limit as it approaches infinity must equal 0 for it to diverge. If it equals any other number but 0, it diverges. Number 5, you can do the same test. The limit as n approaches infinity of n squared over ln n. Whenever the top is more powerful, of course, it's going to go to infinity. So this definitely diverges by the nth term test. Number 6, this is a geometric series. I need to know what the common ratio is. So the common ratio is 1/2. That's what I'm multiplying every time. So that means it converges. This again is the geometric series test. And then if you start with the first term and then 1 subtract what the common ratio is, that's 1 divided by 1/2, and the answer is 10. Number 7, this common ratio is 3/2. That's what you're multiplying. Because it's bigger than 1, this diverges, and there's no number defined. Number 8. Do you want to see my deal? That's how I felt the other day. All right. I'm okay. Number 8. I'm sure you felt like that once or twice before. Oh, it's point, see? 0.2, 0.04, 0.008, and so on. So if I look, what am I multiplying times every time? You're multiplying, if you divide, it's 0.2. 1 times 0.2, 0.2 times 0.2, and so on. That's less than 1. So this converges. And then you take the first term and then 1 subtract the common ratio. So 1 divided by 0.8. 0.8 is 8/10. So the reciprocal will be 10/8 or 5/4. Number 9. So the infinite sum, n over sine n. So what we do is write it as a limit as n approaches infinity. See, does this limit, does it equal 0? And so the problem is the denominator. So this diverges because the denominator oscillates up and down, up and down. It doesn't converge to a number. And this is the nth, what do they call it? The nth term test, that's right. All right, number 10. n equals 1 to infinity. So if we write this as a limit approaching infinity, if I divide the power terms, they have the same base, subtract, you're left with 3 to the negative 2. So if you go n subtract n plus 2, right, subtract the exponents, you're left with negative 2. And so 3 to the negative 2, it diverges because the limit needs to approach 0 in order for it to converge as a series. Number 11. So again, when you think of this, did I write it down correctly? E to the n pi to the n plus 1 Oh, okay. How about we write it like this? Oops. I was having a hard time seeing it at first, but if I rewrite it, e to the n is just a number. And then write down pi to the n plus 1. But in order to do that, in terms of that, so it's geometric. The common ratio is e over pi. That's what it says. And e over pi is less than 1, so it converges. And so the first term, plug in 0, and you get 1 over pi. And then that's fine. I'm going to let this question go. It felt very confusing. But that's the answer. You could simplify it, but I'm going to let it go. Number 12. I think you would see e times pi if you multiplied it out. Like if you looked at the first term, it's 1 over pi. If you looked at the second term, plug in 1. It would be e over pi squared. So what did I multiply times? The next one is going to be e squared over pi cubed. Then I'm multiplying by e over pi every time. So this is a good example to expand it and then look, what am I multiplying times? And now I see it much better than this. This I didn't see it well. This I did see it. It's e over pi. And e is about 2.7. Pi is 3.14. So it's less than 1. So it does converge. You know what? Now I'm going to do it. So I'm going to get common denominators. So that's pi minus e over pi. The pi's divide out, and I get 1 over pi minus e as my answer. Beautiful. 12. Don't give up, right? So I see 1/2 plus 2 over 4 plus 6 over 8. 24 over 16, 120 over 32. So if I wrote that, can you see the pattern there in terms of what it is for number 12? So first of all, I'm going to write it as a limit. As n approaches infinity. What's the nth term here? How would I write it? And so when I look at the numerator is actually a factorial. And when I look at the denominator, it's being squared every time. And then when you look at it, 1 over 2, 2 over 4, 6 over 8, 24 over 16. Can you see how the numerator is becoming more powerful than the denominator? So as you keep going and going, this is going to diverge. That you can see the top is more powerful than the bottom. Because you can see, as it's going on, the top is getting more powerful and more powerful. Number 13. Sorry, this isn't n squared. This is 2 to the n, I should say. Because 2 to the 1, 2 squared, 2 cubed, 2 fourth. There you go. But it still diverges. 13. So the base is sine e to the 10. Now, the value of sine can never be bigger than 1. 1 is as big as sine e would ever get. So sine e to the 10, the value of all of this is going to be less than 1 by the unit circle. So because of it, it converges. And then the answer is plug in 1 first, and you get sine e to the 10. 1 minus sine e to the 10. Good enough for me. 14, last one we'll do for this video. So the base there, the absolute value of it is 5. So that means it diverges because that's larger than 1. All right, Mr. G Math over and out. We are going to continue 15 on the next video. Till next time.